Physics Part 23. Application determination of the acceleration of free fall. A steel sphere is released from an electromagnet and falls under gravity. As it falls, it passes through light gates which switch an electronic timer on and off. The acceleration of free fall can be determined from the values of the time intervals and distances. This is an experiment in which electronic switching is essential in order to reduce the potentially very large error caused by the reaction time of the experimenter. Here, timing to 1/100th of a second is essential. Determination of the acceleration of the free fall. Digital timer, analog stop clock, using a protractor. Application: measurement of the frequency using a cathode ray oscilloscope. A cathode ray oscilloscope (CRO) has calibrated time base so that the measurements from the screen of CRO can be used to give values of time measurements from the screen to give the values of the time intervals. One application is to measure the frequency of the periodic signal, for example, the sine wave output of a signal generator. The signal is connected to the Y input of CRO, and the Y amplifier and the time-based controls are adjusted until a trace of at least one, but fewer than about 5 complete cycles of the signal is obtained on the screen. The distance L on the graticule of the scale on the screen, corresponding to 1 complete cycle, is measured. It is good practice to measure the length of say 4 cycles and then divide by 4 so as to obtain an average value of L. The graticule will probably be divided into centimeter and perhaps millimeter and 2 millimeter divisions. If the time-based setting is x, which will be in units of seconds, milliseconds, or microseconds per centimeter. The time t for cycle is given by t is equal to Lx. The frequency of the signal is then obtained from f, which is equal to 1/t. The uncertainty of the determination will depend on how well you can estimate the measurement of the length of the cycle from the graticule. Remembering that the trace has finite width, you can probably measure this length to an uncertainty of about -+2 mm. Measurement of the frequency using a CRO. As with most instruments you will use, your laboratory time will be so limited that you will probably have to take the time-based setting on trust. However, it is worth thinking about possible methods of checking the calibrations. You could try checking against a calibrated signal generator, but who is to say which of the signal generator or CRO has the correct calibration? Another method would be to connect a microphone to the Y input and a sound tuning fork of known frequency near the microphone. We've got an example for it. The output of a signal generator is connected to the Y input of a CRO.